In this example, we are given the following set of parametric equations. X is equal to 6 plus 2 cosine t. Y is equal to 5 plus 2 sine of t. And t ranges from 0 to 2 pi. We are asked to turn this into a rectangular equation, or in other words, to eliminate the third variable t. As far as knowing what to do to achieve this, it's going to take just doing several problems until you start to sort of see family resemblances among different sets of equations. But what I can say is that because I don't see x squared, y squared, or cubed, or anything else for that matter, I simply see x and y, first power, and x is directly related to cosine and y is directly related to sine, I have a suspicion that we're going to be getting something that's either a circle or maybe an ellipse. That's my gut instinct, but I don't actually know until I go through the steps. Okay. One thing that's useful to keep in mind, I'm not doing any steps on this yet, I'm just writing things to keep in mind, is that cosine squared plus sine squared is equal to 1. I can use this to try to simplify stuff. If I can square the cosine and square the sine, then they just go away and become 1, and that's convenient. I'll also keep in mind that the radius squared is equal to x squared plus y squared as well, again for a circle. And so if I keep that in mind, and the final thing, I note the equation of a circle is x minus the center coordinate squared plus y minus the center coordinate squared is equal to, well, that radius squared. And if you work this out, you can see that that works out just well, or just fine, I should say. So let's actually start manipulating this. So if I'm looking at this, the equation of a circle, I can see that I could subtract the 6 over, and I could have x minus 6. Likewise, I could do the same thing for the y. I could have y minus 5. So let me do that. I'm going to take each of these and perform that operation. So I have x minus 6 is equal to 2 cosine of t, and I have y minus 5 is equal to 2 sine of t. Okay, so far so good. Well, what I have in the circle equation is that these are squared, so let me square both sides of each of these equations. So if I do that, x minus 6 squared is equal to 4 cosine squared, and y minus 5 squared is equal to 4 sine squared of t. So far so good. Now notice if I simply add these equations, I will have what looks like the form of a circle. Sort of. It doesn't look like I'm going to have a nice simple r squared over here, but maybe some stuff will simplify. So let's add these two equations together. And if I do that, I get x minus 6 quantity squared plus y minus 5 quantity squared is equal to, well, if I add these, I have 4 cosine squared plus 4 sine squared. So now notice this looks awful similar to cosine squared plus sine squared is equal to 1. I just have that pesky 4 there. Well, what I can do with that is I can just factor out the 4. So I have 4 times the quantity cosine squared of t plus sine squared of t. And what is that? Well, that's just 1. So I have the equation of a circle. I have x minus 6 squared plus y minus 5 squared equals 4. Because, of course, 4 times 1 is just 4. And so underneath here, I can see that the center of the circle is at 6, 5. Remember that in the equation of a circle, these are the center coordinates. And I can see that r squared equals 4, or in other words, r is 2, because 2 squared gives me 4. Don't forget that you have to take that into account, the fact that it's not just r, but r squared. So now that we have all of that, the final thing we were asked to do is to actually graph the equation. Well, since I already know this is a circle, and it's centered at 6, 5, I'll just mark these things by 2. So 2, 4, 6. 2, 4, 6. And so 5 is basically right here. Remember, the center is not actually part of the circle, but it's very useful for us for drawing the circle. And my radius is 2. So that tells me that I would go out 2 in every direction. So from 5, I would go down to 3 as far as the y is concerned. And I would go up to 8, so that would be about up here. And on the x-axis, I would go over to 4 and over to 8. barring my, atrocious drawing skills. Now, one thing I want to point out, though, is that it's very tempting to be like, cool, this is a circle, connect it, we're done. However, we are told the range over which t goes. So, for example, if we were told that t goes from, say, pi over 2 to pi, which we weren't, we were told it goes from 0 to 2 pi, but just to make the point, if we were told that it goes from pi over 2 to pi, then I would have to remember that, okay, well, pi over 2 would start straight up, so that would be here, and then it goes to pi. Well, pi would be down here, like so. So I have to be very, very careful about that. However, in this case, we are told that it goes from 0 to 2 pi, which means, start here at 0 and go all the way around pi over 2, pi, 3 pi over 2, 2 pi. So yes, in this case, it's just an entire circle. But you do have to be careful about that and check the bounds on your t variable. And that is this example.